Hello everybody. So this is ratio and rate problems. We're just reviewing ratio and rates using word problems. And that can be found in your textbook under Chapter 1, Lesson 7 if you wanted to look in there. Alright, the first thing we're going to go over is a little real world link. So a little link to the real world. For the games, it says that we would go to an arcade and they sell game tokens individually or in packages, and they are having a sale on token packages as shown below. So they say for one package it's $5, for two packages it's $10, and for three packages it's $15. I got that information by looking at my little table here. It wants to know how many token packages can you buy with $20 or $25. So basically we're extending our table here. Sorry about all the crazy noises in the background. We're extending our table here so that it includes 20 and 25. And so if we were to do that, I would see that it would be 4 packages and 5 packages for each of those. When you're writing this down, you could probably just show this part and then make this. The next thing is that it wants us to say what the unit price is. Well, luckily, for one package, it's $5, and so that would be our unit price. One package for $5, or $5 per pack. That would be a better way of writing it for one pack. Okay. So then it wants us to know how much it would cost to buy 6 token packages. So again, we're just going to expand here and go 6 would be $30. Since it's $5 a pack, 6 of them would be $5. So it would be $30 for 6 packs. The very last question is asking us, the arcade sells individual tokens for $25 or $25 cents each. If a token package contains 25 tokens, how much would you save by buying the package of 25 tokens instead of 25 individual tokens? So this one I want you to do on your own. I want you to pause this video and figure out how much 25 tokens at 25 cents each would cost, and then compare that, mean subtract, and find out how much more you would spend if you were buying the individual tokens. Pause the video now. Alright, and your answer should have been $1.25 is what they saved, or how much more they paid to be able to buy individual tokens. So it would be $6.25 if we bought them individually, but $5 for a package, so the difference is $1.25. Alright, so we're going to look at this one. It says that you can use a bar diagram or equations to solve ratios, or with equivalent ratios to solve ratio and rate problems. So the Heritage Middle School has 150 students, and 2 of the 3 students in Mrs. Mason's class prefer gel toothpaste. It's a big debate. Use this ratio to predict how many students in the entire middle school prefer gel toothpaste. So using the idea that it's a 2 to 3 ratio, that for every 2 kids, or out of every 3 kids, 2 of them like gel toothpaste, we would just set this up as a ratio table. So we're saying here's we're not going to use the ratio table, we're going to use the diagram. So we've set up this bar, and this is what I'd like for you to be copying right now. We've got the 3 spaces because it's 2/3. So 2/3. 2 out of 3, right? And to be able to figure out how many that makes in those 2 sections, we need to take the 150 and we need to divvy it up into those 3 boxes. So it would be 50 students here, 50 students here, and 50 students here. That makes 150 total students, of which 100 of them would like gel toothpaste. That's really interesting, right? The second method is that you could use equivalent fractions. You could write the equivalent ratio. So I know how many total students there are, and I want to figure out how many students would like toothpaste out of those students. So every 2 students there are, or out of every 3 students, 2 of them likes toothpaste. How did I go from 3 to get to 150? I multiplied times 50. And would I do the bottom? I do the top. And so 2 times 50 is 100. So 100 students would prefer gel toothpaste. So those are the 2 methods, making the bar diagram or setting up the ratios to find the equivalent ratios. Now they give us a little note here, and it says equivalent ratios. Notice that the numerators of both fractions in method 2 refer to the number of students who like gel toothpaste, and the denominators of both fractions refer to the total number of students being referenced. So they're saying that, notice that the bottom reference the same thing, the total amount of kids, and the top reference just the kids that like toothpaste, the gel toothpaste. All right, so the next one is the ratio of the number of text messages sent by Lucas to a number of text messages sent by his sister is 3 to 4. This totally is reminding me of that talk video. Lucas sent 18 text messages. How many text messages did his sister send? So I guess it's like the big family debate of, you know, who's the bigger text messenger or something. And so we're trying to figure out how many his sister sent, that if he has, out of 7 possible, he sends 3 of them, and the sister sends 4 of them. Okay, so it's out of a total of 7. You notice that? Then we can say, okay, well, there's 18 text messages altogether, so we need to divvy those up in this area to be able to figure out how much this area will total. So 18 messages sent by Lucas means that this would be 6, 6, and 6. I know, calm down. And that would make a total of the 18 messages. Over here then, if these are all 6s, then these will all be 6s as well, and then I can add those all up, and it tells me that she has 24 text messages for every 18 of his. Of course, you could also set it up as the equivalent fractions and say here's, and I like how they did this where they say, I like to say Lucas and sister. Put a little L and a little S. And then set it up side by side, and this is very similar to that number 9 problem that you guys are going to do or have done on page 67. So we have Lucas's sister sent 4 for every one that Lucas sent 3. And so if we know Lucas sent 18, we can say, okay, how do we go from 3 to 18? Luckily, we don't need a middleman, but remember we learned middlemen too, so if it doesn't go nicely, we can find a middleman. But we're going to multiply times 6. And so what I do to the top, I'm going to do to the bottom, and I get my 24. And so Lucas sent 18, his sister sent 24. You're going to do these 2 problems on your own. So I'd like for you to pause the video now, and when you return, I will have the answers and go over them briefly. Pause the video. All right, so here are my answers. For A, it says that 4 out of 5 people prefer creamy over chunky peanut butter. And then it says that there are 120 people shopping at the grocery store, so we're trying to figure out how many like the peanut butter. So we're looking for the one that's equivalent with the 4, because we know that the 5 and the 120 go together. So what I've done is I've set up both methods. In my picture, I set up my model with 5 boxes altogether, 4 of which account for the people that like the creamy. And then I took the 120 people and I had to divvy that up into the 5 boxes. So I did 120 divided by 5 to figure out what number to put in each box. That ended up telling me that I'm going to do 24. And so I put 24 in each box. And then I figured out how many people of the 4 boxes combined, how many people would that come out to? And that's 96 people prefer creamy. For B, it says that the survey found that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people selected eating at a restaurant in the survey, how many people took the survey? Here's what I think a lot of you might have done if you got this wrong. The correct answer is 505 people took the survey. You might have thought that it's 400. So anyway, let me just go through it. So I set up my boxes, and there are 15 altogether, and 12 of them are how many people like going out to eat instead. So then that means that in the long run, 400 people that were surveyed like to go out to eat. So that 400 only accounts for this area right here. We want to know what the total area is. And so to figure out what the total area is, we need to figure out what goes in every box and then add them all up. So if 400 people are 12 out of the 15 boxes, I'm going to take the 400 and I divide it by 12. It comes out to 35 people. And I know these are some big numbers, so it's kind of hard to visualize, but I put 35 in each of the boxes, including these over here, and I figured out that the people that did not want to eat out in restaurants were 105 people. But that's not what the question is asking. It's asking you how many people took the survey. So once I found that out, I knew I would just take the total of the 400 plus the 105 people, and that altogether is 505 people took the survey. All right. So our next example, we're going to talk about using double number lines or equations to solve rate problems. So it says the Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? So if we were to make a table like we did in the last 2 sections, we would be saying, okay, it's 4 gallons for 105 miles, and we want to figure out how it is at 6. Well, I can't go from 4 to 6 easily, so I need to figure out a middleman. That's where my mind instantly goes. Now, I like that they show this example with the number line, because that's also a very helpful tool. They're just showing, here's our number line. We'll talk about the miles on top and the gallons on the bottom. And so, obviously, for 0 gallons of gas, you go 0 miles. They told us for 4 gallons of gas, we go 105 miles, and we're trying to figure out 6. What is it going to be? How far can we go with 6 gallons of gas? So what they've done in our picture here is they figured out what the unit rate was, because remember that's one of our strategies, that we can find out the unit rate. When we figure out the unit rate, it's actually a decimal, which I know normally, typically, it's not something you guys like to see, but in ratios and rates, it is very, very possible for part of your ratio or your rate to be a decimal answer. So it's important. That's the difference between fractions and rates and ratios. Fractions, you can't have a decimal in the numerator and denominator, but for rates and ratios, you absolutely can. You can have a decimal. All right, so they figure out what 1 is. So we figure that out by doing 105 divided by 4, and we end up finding out that that's 26.25 miles. So this number would go in here. Then we take that number and we would multiply it times 6 so that we can figure out if it's in 1 mile that far, how far would it be in 6 miles? Well, I just multiplied times 6. So we find that and we run with it. Using the table up here, my middleman would have been maybe a 2, and I knew I would have to divide by 2. Well, when I divide by 2, I would have found that that's a decimal answer itself, and so I would have put 52.5. And then to go from 2 to 6, I would have multiplied times 3. So I would have done that to the bottom, multiplied times 3, and I would have gotten my same answer here of 157.5 miles for 6 gallons of gas. So using the diagram, and I'm sorry that mine's so sloppy, theirs is much prettier than mine is, or if you want to use the table, both of those methods will work the same. One of them you find the middleman, the other one you found the unit rate so that you could find it. That's also a middleman, right? The unit rate's a middleman? Absolutely. Here you're going to do this example. I'd like for you to attempt doing it using the number line, and then if you have a problem with the number line, you can use then the ratio table. So try it and come right back. Pause the video now, please. Okay, so here are the answers. We've got, I used the number line here, and I put calories on top, scoops on the bottom, and I said for every 0 scoops, there's 0 calories. Then I put my 3 scoops for 810 calories, and I put my 7, and I was trying to find out what my box here would be. So I figured I'd find the unit rate, since there's not a good place between 3 and 7. And so I found the unit rate was 270 calories per scoop, and then I took that and I multiplied it times 7 so that I could figure out how many calories it was for 7 scoops. And so ultimately it was 1,890 calories for 7 scoops of ice cream. And then I showed my table, which basically I did the exact same thing with my my table. So the ratio table also used the same purpose. You can use either method, just recognize both of them. All right, guys, last but not least, you're going to be doing number 9 on page 76. It says find the error. Alyssa's mom teaches a preschool, and there's one teacher for every 12 kids at the preschool. There are 276 students at the preschool. Alyssa is setting up equivalent ratios to find the number of teachers at the preschool, find her mistake, and correct it. So I've got the rubric already uploaded on Canvas as well as the assignment. I want to make sure that you are looking at that rubric to make sure that you covered all the bases. You definitely need to solve this because you need to find the mistake and correct it. And explain to her, like write a little note to her, Alyssa, what did you do wrong? This is what you did wrong. Make sure it's very clear so that anybody reading this would know and understand what she did incorrect. All right, guys, that's it. Thanks so much. Sorry, 15 minutes, almost 16 minutes. Have a great day. See you in school. Be ready for that test. Bye.